Use the graph to solve the inequalities. All right, so in this one, we're given a graph, and we can see it's a parabola, or basically a quadratic function, and they're telling us in part A to determine where the function is greater than 0. So what they're referring to when they say greater than 0, remember that this is essentially y. F of x is the same as y. So they're asking, where is y greater than 0? Remember, your y-axis is greater than 0 from here up, right? And so basically any place where you have a graph that's above the x-axis, we're talking about an area where the function will have a value that's greater than 0. So all we're really describing is along the x-axis, where are these points occurring, right? So where is this part of the curve occurring according to or along the x-axis? So what you want to think about is, okay, looks like from here, this portion of the x-axis, and this portion of the x-axis, we end up having positive y values. In between, we have negative ones. So let's first talk about how to write that in interval notation. So we'd say from negative infinity on the x-axis up until it looks like -3, right? We have a positive graph, right? In other words, this part of the graph is above the x-axis. Then we would pick up from there at +3, right? Not including +3, because at +3 we have the value 0, but just after +3, so use a rounded parenthesis, going up to positive infinity on the x-axis, all those places have, again, a part of the graph that looks to be greater than 0. And so that's it. That's basically the areas where f of x is greater than 0. Now, for part B, we're looking for areas where y is less than or equal to 0. Where y is less than or equal to 0. Well, that's areas on the graph where we're below the x-axis, right? Because the y values here, below the x-axis, are the ones that are negative, right? So where is that occurring? Well, it looks like it's occurring along the x-axis here, all this area in between -3 and 3, because there is where the graph is below the x-axis. So basically what we're looking for then is a way to describe that region. Now, here we have the equal to sign, equal to 0, which means we can actually include the -3. So on the x-axis, that area goes from -3 to +3, but we can actually include those because we want to include the possibility that the function is equal to 0, and at both -3 and 3, the function is indeed equal to 0. So from -3 to 3 is where the function is less than or equal to 0. So those are your two solutions, and we're done.